Hey guys, David here and welcome to another Dark Art Guitars video. In this video I'm going to show you how I made these custom angled pickups and how you can make those too with just very basic tools. You don't need a CNC, you don't need a 3D printer, none of that fancy stuff, yet these are fully custom and I'll show you how you can do that too. Now the basic premise here is that first we are modeling these on the computer, which we will look at in a second, and then we're going to send off the bobbins, which are what we wind the wire around for 3D printing. Well, of course you could print them yourself, but by sending them out to this video's sponsor, PCB, we can get these 3D printed in all kinds of different materials. Like here, for example, I'm using nylon, which is like powder that gets fused. So that's not a 3D printer that most of us have at home. Or of course, if you want just maximum detail, you can get them resin 3D printed, or many other options as well. And then for the base plate, which you would traditionally CNC machine, we're actually going to make use of a PCB, and that's a very cost-effective and really cool method of making these base plates. You get the structural rigidity of a PCB, but also you can integrate some cool lettering. I have my logo here that is super shiny, and as well as you can make them just plug and play by integrating a connector. Since it's a PCB, we can have traces on here, and I'll show you how you can do that all from the model as well. And then the best thing is that these surfaces, they're not very expensive. You can check out in the link down below how much this will cost you, but for these pickups together, they are still probably about half the price as a commercial set of humbucking pickups from, I don't know, Seymour Duncan or DiMarzio or whoever you like. Now, the one machine that you will need, of course, is a pickup winder. And while this might sound intimidating and expensive, and you can definitely get into some really fancy stuff there, you can build a very basic pickup winder yourself from stuff that you have lying around. I built mine from some spare 3D printer parts. I just kind of cobbled it together. But there are many guides online here on YouTube to build it, from like old sewing machines, lathes, 3D printer parts, many more. And if you don't want to go the DIY route, there are also quite affordable off-the-shelf versions that you can buy for your pickup winder. That's not really a way to get around that if you want to make your own pickups. Apart from that, you'll need a soldering iron to put it together, some screwdrivers, but all of that stuff you probably already have if you're building guitars. Now, before we get into the nitty-gritty details, let's back up a little bit and talk about how pickups work. Now, if you already are an expert at pickups, feel free to skip this section. I'll get into the more interesting parts later. Now, the basic premise is that we have two coils in case of a humbucking pickup. I'll be showing everything here as a humbucking pickup, but for a single coil pickup, as you might find on Stratocaster, it's the same, just only half of it. Now here we have two coils of wire. That's a very, very thin wire, roughly the thickness of a human hair, that is wound around these little plastic bits here that we call bobbins for a couple thousand times. In the case of this pickup, 6,400 times for each one of the two coils. Then in the center of the coils, for each string, we have either a slug, which is just a little metal part, or we have a screw that is height adjustable. Now, traditionally, you would have one row of slugs and one row of screws, but you can have also 2 rows of slugs or 2 rows of screws. It's kind of up to you. There will be slight tonal differences, but there are many, many different aspects about pickup building that make small differences. So it's really hard to quantify what the difference between a slug or a screw is in terms of tone. Then the point of these metal pieces that we have here in the middle is that underneath of the pickup, which you can't really see on these closed up ones, but I show you an in progress shot here, we have a magnet. This is quite a strong magnet. And these magnets are what creates the magnetic field, which can be disturbed by the strings vibrating, and that disturbance of the magnetic field is what the coils pick up and create an electrical signal out of, which then is picked up by your amplifier or your audio interface and creates the beautiful sound. For the magnets, there are also different options. The most common ones for humbucking pickups are either ceramic magnets if you want really high output. That's what I'm using here for the bridge pickup. They have quite a almost harsh sound to some people, but they give you the most output for like more aggressive metal genres. These are really good to use. But then if you want a bit more dynamic response and a bit more of a mellow sound, then Alnico magnets are where it's at. And there's many different Alnico variants, but what I'm using here is an Alnico 5 magnet for the bridge pickup. Just for completeness sake, in some single coil pickups, actually the slugs are individual little magnets instead of having a magnet underneath. But we will not cover that in this video. Now I've already hinted at bridge and neck pickup as two separate things here, and they are kind of similar. In most cases you could swap them around. However, you want to kind of target the bridge and the neck pickup to the sounds that we want to get out of them. Usually if you want the most aggressive and intense sharp sounds, then you'll be on your bridge pickup anyhow. So having a ceramic magnet there and a very hard pickup is a great choice. Then if you're switching to the neck pickup, chances are that you want a little bit of a warmer tone, something a bit more friendly. Maybe you're going into a nice solo lead, and that's why here I'm using an Alnico 5 magnet, and there are also fewer winds on these coils. Fewer winds means that there will be slightly less output voltage. Basically, as many times as you wind it around, it just kind of adds up more electrical signal the more you wind it. There's some other side effects to it, but for the purposes of this, let's keep it at that. So having 6,200 winds here instead of 6,400, it's a small difference, but it's just gonna create a little bit less of a high output and just kind of a bit of a more friendly, more dynamic pickup for the next position. You can also play around with the different types of wire that you're using. The most common gauges, that's the thickness of the wire, are 42, 43 and 44 gauge wire. And if you're not familiar with the gauge system, the higher the number, the thinner the wire. And here I'm using 42 gauge wire. In general, you want to use a lot thicker wire. That just generally means that there's less resistance and you get a nicer tone. However, having thicker wire means that you can get fewer coils onto your bobbin. Of course, also that means there's more material on there, so there's a slightly higher cost to having thicker wire, which is why a lot of cheap pickups tend to go with 44 gauge wire, as you just need less of the wire to get the same result. But there are definitely benefits to using thicker wire. That's why most people that are hand winding primarily use the thicker, like 42 gauge wire. There's another nice benefit to 42 gauge wire is that it is a little bit stronger. It doesn't snap quite as easily, but it's still a very, very thin wire, so snapping it is quite easy. There's also different coatings available, but unless you're getting into vintage pickups, there's really no reason to not just go with the modern polynylon coatings. It's the most cheapest ones available and will generally perform really well. If you're trying to emulate like a vintage tone, then you can get into enamel coatings and all of that other stuff. But a lot of that is not really necessarily scientifically proven. It's just that's what we used in history, and so people like to use that now as well. Please don't shoot me for that comment. So now that we are kind of have an overview of all of the different aspects of these pickups, what makes them tick and how they work, the different components that we are using, let's jump over to the computer and I'll show you how you can design your own pickups. Here we are inside of Fusion 360 and I have the design loaded up for this pickup. Now, as you can see here, this is the pickup that we are building here in the reality, 10-degree angle, 6 strings, 52mm string spacing. However, this design is not just this pickup. I made this design fully parametric, so if we open up the parameters here, we can change the string spacing, the angle and the number of strings. So let's say instead of the 52mm, we just want 50. Easy enough, it just updates automatically. But that's fairly basic. Let's say instead of 6 strings, we want an 8-string pickup. Then, boom, it goes ahead and it adds the additional slugs. Now this is of course way too tight spacing. Let's move this to, let's say, 72mm. And also this is updated automatically. And then of course we can also change the angle. Maybe we want an extreme angle of 25 degrees. Or just an angle of 0 degrees. Let's go back to maybe 15 here. And click OK. Now you can see some other stuff down here. you don't really need to worry about that. That's just some mathematics that are needed to make all of these parametrics work. Mainly the angle makes it quite a bit more complicated, and there's some math that needs to be done here. Now all of this is driven by just a couple of sketches, and actually primarily one, this main sketch here. If we look into it, this is where all the holes are defined and all of the other stuff. Now if you want to go ahead and change any of the overall features, like for example the diameter of these holes out here, you'd have to go in here into the main sketch. Also if you want to change the diameters here for these holes. Now I have dimensioned these here so that it works quite well with the tolerances of the nylon 3D printing. However, if you're doing resin 3D printing, the tolerances are a bit tighter, so you can go in here and change some stuff. So there is a bit of trial and error involved if you use different technologies. Then there is a second sketch here for the PCB. That's just like a projected sketch. Nothing is defined in here. And I also designed an optional cover that scales accordingly, and that is defined in here, but it automatically adjusts its size as well to the other stuff. The last sketch you might want to worry about is the engraving sketch. And here you can change whatever text or stuff you want to engrave in here. And I made sure that this also is fixed to the angle. And then you can go in here, change the fonts, change the text, whatever you like. Right now it's just cut out of one of the two bobbins. The way I have it set up is that the bottom here is always the screws and the top is slugs. Now if in the end you want to build a pickup of 2x slugs, you can just 3D print the top bobbin twice and use it for both of them. They are identical otherwise. This way you just get both options. And if you then want to have the text engraved in the top one, you can go in here into the feature for the engraving and just select the different text. So we can say we want this one engraved as well. Give it a second, and then it will automatically, of course, also update that one. Now from here we can just go ahead and use the regular utilities here and export that for 3D printing, send that off, or 3D print it ourselves. Nice and easy. But what about the pickup, the PCB down here? This is just a very simple body here. Now, inside of Fusion 360, there is now also the PCB design software, which is really cool and allows you to, well, just take this body and turn it into a PCB. So we can go here to create PCB and create associative PCB, which is going to keep it linked. I've already done that here, and that then creates this 3D PCB. Now, it will not look quite like this right away, and as you can see, this does not actually match right now. And if we are here, let's save this design. Then we can go into the 3D PCB space here, and since this is linked to the other one, we can go ahead and update it here. As you can see, the outline of the shape now has updated. You can see also that some of the other stuff has not updated and is still, because in the PCB design in Fusion 360, it is kind of all backwards and there's a million files. Like the overall board shape, if you're using 3D PCBs, is defined from that. But then you also have the 2D PCB, which defines all the copper layers, and you also need the schematics. All of that then together is organized in a electronics design project where all of these are linked together. You can also see that the link is not perfect. While we have updated here our outline, we are missing a couple of the holes. And if we look at the sketch here, we have these the sketch in here, but did not realize that we also wanted those holes cut out. So we'd have to go in and manually tell it again that, hey, we also want these holes cut out. Then if we want to update the rest, we can, from the 3D PCB here, use this button to push it to the 2D PCB. If we do that, then here we are now in the 2D PCB design, and this has also automatically updated. Now, what will never automatically update, it's just not supported, is, for example, the connector here, it's just in the same position as it was before. You will have to manually move it to wherever you want. And if you want to angle it according to the pickup, then you will manually have to go here into the properties and set your angle from 90 degrees to, let's see, 75, I believe. That's the wrong direction. So 105, so 90 degrees plus the 15-degree angle that we set. And now you have this angled in accordance to it. And then if we have any text in here, like for example for the ground here, you would have to go in and also manually change that. Now if you're just doing a very basic structural PCB without any connector and no text, the basic overall ground port should update automatically and you don't have to worry about that. If you want to add some more text, you can just use the design space here, and then in document under draw there's the text, and then here you can just enter whatever text you like and make sure that it is on one of the text layers that you are going to export and send to your PCB manufacturer. Then finally, for all of the electrical stuff, you cannot just add in this connector here into the PCB design. There also needs to be a schematic linked. So there's this very simple schematic. Since I just want to have simple connectors, so it's just this connector in here, and it has one net defined, which is the ground net. The only reason why we need that is so that the polygon pore, which we use as like the base layer, properly connects to that pin. And this means that like the base plate will be grounded in the end. If you want to add additional circuitry, for example, making it an active pickup, you can very easily add all of that circuitry directly to the base plate, which is quite convenient. And then you could, of course, add all of that in here. Now, while I'm using a standard component here for the schematic connector, so that we just have the connector without any silk screening or anything else, I have created my own connector here, and that should hopefully be properly linked with it. And that just means that it's just the pads themselves and the holes, but no outlines. And then I'm just manually creating a label for the ground, but even that is technically optional. Now, I have just showed you how to use these files, and that is for a good reason, actually. For one, showing you how to design all of it from scratch would make this video prohibitively long, and there's a lot of, I don't know, background Fusion knowledge to get it to fully work. So if you already know Fusion, feel free to have a go at it yourself, but you can also just download this file for yourself. I will have it linked down below in my brand new store. And no, it is not quite a free design. I do need to pay for my coffee somehow. So there is a small price. And for the first 2 weeks after releasing this video, it will be half off. So just $5. And then after that, it will go up to $10. But I think that is still quite reasonable, considering that this is fully parametric and you could just input the dimensions you need, the angle you need, and it will automatically give you all of the files that you need. Then when you have finished your files, we can come to this video sponsor, PCBWay. Now, of course, there's many different manufacturers, but I've been working with PCBWay for many years now, and I've always been very happy with their solutions. So for the PCBs, you can just go here to PCB Instant Quote, select all of your different dimensions here. Now, I, for myself, like to use the 1.6 millimeter, just the standard thickness. I feel like is a good thickness for a PCB, for like a pickup base plate. And then what I always do is go for the black silk screen. I think it just looks so much better. And then the rest, basically, you can just leave as a standard. These are very simple PCBs. So if you just fill out this basic and click calculate, you can see that these pickups qualify for the just $5 base fee for the pickups. And if you choose the green silk screen, it's just 24 hours, but I always like to go for black. Just the regular glossy black does not add anything to the price, and I think it just looks so much better. You can also go for matte black, but that will sadly increase the price. Then the last thing that I like to do down here is just removing the product number. It costs an extra $1.50, but otherwise in the silk screen they will add the product number. It makes it easier for them, but I think the extra $1.50 is definitely worth it to have a clean look. Then for the 3D printed parts,
let's open up a new window here, select 3D printing, and then we can drag and drop our STL files in here. So I just added in one example here. We can double check that the design is imported here correctly in the 3D viewer. So yes, we have here this bobbin that we want. Then we can select here the quantity. For most processes, it makes sense to get at least 2. As you can see, the total price doesn't change, so it's always good to have a backup. And then there is a whole lot of different materials here to choose from. What I'm using for this example is the nylon in black. That has kind of a coarse texture, but I really like the texture of it, and it is also super strong. Another good alternative, if you want something a bit more clean, is going for resin, and they have their standard white one, or you can go with black resin, and resin will also be one of the most cost-effective means. For the screws, you can get them to automatically thread all the holes for you. That will cost a little bit extra, and you have to provide them with a drawing, but I find it easy enough to either just thread them with a screw by hand, or even better, using a tap in and just quickly going through the threads. It takes a couple of seconds and just makes it a lot cheaper. Now, some other materials that I want to highlight is the transparent here. I've used this one before for the Cyberpunk guitar pickup bobbins, and it just like absolutely glass-like. And that is another really cool look that you could go for.
So now that we have our bobbins and our base plates in hand, the other parts, I'll have some couple sources linked down below of places that sell pickup parts. There's a plethora around, and my sources are more EU-centric, as I live in Switzerland, but if you live in the States, and then there's plenty of other suppliers there as well, where you can get the screws, the slugs, the magnets, and all of that good stuff. To wind the pickups, we do all the different coils individually first, of course, before we then assemble them together later. And since this wire is very, very thin, it's very easy to snap it. So the part that you actually solder onto later on the outside, we want to make sure that that's a little bit of a stronger wire. So to the start of the wire, we're going to solder what is called a hookup wire. You can get these at most pickup suppliers as well. It's just a very thin gauge insulated wire, and this we will feed in through the little hole in the pickup, and then have it soldered to the wire. Now with the pickup wire, there's actually a very thin layer of insulation around. And in the case of the polynylon wire, you can just use some solder on the tip of your soldering iron and stick the wire in there, and it will burn off the insulation, and that means you can actually solder to it. This insulation is needed, since otherwise the winds that are going around that are lying on top of each other would create an electrical contact. This also means that if we just wind insulated wires over top of our base layer, we don't really need to heat shrink this, but I still like to use some little cloth tape on the bottom to hold the wires in place. That makes it easier to get started and make sure that it all stays nicely in place. Then we can mount it on our pickup winder, and from my winder I find that 1000 RPM is pretty good speed. It's a nice balance between the pickups not taking forever to wind, but it's not being too fast. So I set it to 1000 RPM for my winder, set it to 6400 turns for my bridge pickup here. You can of course experiment with that depending on what kind of pickups you are building. And then pressing start and just kind of gently guiding the wire. You want to keep a little bit of tension on it, but you'll quickly notice if you kept too much tension, then it's going to snap. Most likely your first 1 or 2 coils will not turn out. Either they will be too loose and the wire starts tangling itself and flying off, or you'll snap the wire eventually, but that's just to be expected. So just make sure to buy a bit of extra wire if you've never done this before. After a while you get the hang of it and you know how much tension you want to put on there, that you can lay it down nicely. Then for the technique of how you want to traverse it, you go fast, you go slow. There's a million opinions out there, and I'll just tell you what I do, but that's in a lot of people's opinion, where kind of the secret sauce of how a pickup sounds comes from. It's fairly easy to reverse engineer what kind of magnets you're using, how many winds you have, what wire you're using. But the thing that is basically impossible to kind of reverse engineer is how is it wound. But the main difference you get from winding differently is if you have the wire neatly laid next to each other and then on top and then on top, you get a very compact coil. So everything's very close together and there's not a lot of movement or breathing room. But if the wire is further apart, then it can move around a bit more. Now we'll wax pot them later to stop that movement, but there's still more gaps between the wires, and that just creates a little bit of different sound. Now a lot of people like slightly more open with more gaps in between. So the scatter wound term is very popular. But basically, if you're hand winding a pickup, every pickup you wind is automatically scatter wound. Even if you try to pay super close attention and wind it as neatly as possible, your little flash fingers guiding that wire is so inaccurate that automatically you will scatter wind it. So congratulations, you can officially call your pickup scatter wound. So I like to keep a fairly uniform back and forth, fairly slowly, just kind of creating a fairly uniform coil. Every once in a while, I stop the machine, have a look. How am I doing? Do I have it all nicely, evenly distributed? Sometimes, depending on how you set up your stops on either side, you might have a bit too much bunched up on the side or too much in the middle. You can play around with your stops, but just be careful. If you set your stops too far out, you run the risk of the wire jumping off the bobbin, and then you basically have to start over. Then you're just gonna slowly continue winding the pickup. It can get quite meditative, but keep paying attention, otherwise that's when you will mess up. And then 6.4 minutes later, the coil is done, and then we can take it off. And since this wire is very thin and very fragile, we want to protect it with another layer of tape around it. I'm just using the narrow cloth tape here, and I'm also soldering on another hookup wire that we will use later to assemble them together. Then we have created our first bobbin, and we will continue exactly the same for the other ones. And while you do want to make sure that you have them in the end wound correctly and kind of the two coils are opposite each other, don't fall into the trap of thinking you need to wind them the other direction. You actually want to wind them all in the same direction. And then we just, in the end, when we connect it up, we will go from the inside of the bottom coil, that wire goes around to the outside, and then on the other one we connect it not to the inside but to the outside, and that then creates the opposite direction. This ensures that you get the correct polarity for the magnets, and everything will actually be humbucking in the end, and you will get your proper output. You can look at some diagrams to keep track of which direction you want to wind. Then after a meditative session of winding, we have our bobbins completed. All the coils are there. Now we just need to assemble it. It's relatively straightforward. I like to start by putting the little angled connector into my PCBs. If you're not using PCBs in this way, you would solder the wire, the cable that goes to your electronics cavity directly to it. But I like to have this little connector, and it just makes it more easy to solder up. And then I just connect it up. I like to go from the inner wire from the bottom coil to the outer wire, to the outer wire, to the inner wire. There's different ways of connecting it up, and you just need to know which way you connected it to the cable. That way, in the electronics cavity, you can decide whether you want to have it just in humbucking mode, whether you want to have it be able to split the coils, or do all kinds of other wiring shenanigans. But this video is plenty long as it is, so I'll refer you to some other YouTubers on tutorials for the different wiring scenarios. Now, if you have assembled that, added some more cloth tape around, here I like to use the wider version, then you could call it done here if you're just using those pickups for your own guitar. Wax potting is what would be the next step, but it's completely optional. In the past, nobody used to wax pot their pickups. But then when more bigger amps on stage became the norm, you can get some feedback between your amplifier and the wire inside of the pickup, kind of rattling around, and this can create some squealing sounds. Now, if you only ever play quietly in your apartment or with an audio interface, and you don't need to worry about that, wax potting is completely unnecessary. But if you like to play live with big amplifiers and crank it up, then it's probably a good idea to do some wax potting. For that, I am just using a basic candle making setup. Now, it's not ideal. You can get some little smaller pots that are more properly sized, and the kind of opinion varies as well, whether you should be using beeswax, paraffin wax, a mixture of the two. I just keep it simple. I'm just using some basic paraffin candle wax that I already had lying around. Want to melt up enough that your pickup will completely be submerged in it, but you also want to make sure that you don't heat it up too far. I actually made that mistake here. My wax got way hotter than it needed to be, and what that basically does in the end is that when you dunk it in there, the adhesive from the tape will disintegrate, and the tape will come off, and well, you have to replace the tape in the end. If you keep the temperature low enough, then the tape will stay intact and you don't have that issue. And you just put it in there and you should start seeing some small little bubbles forming, and that's the air escaping out and being replaced by the wax. Generally it takes about 10 to 15 minutes until the wax has reached all the way into the windings, and then you can take them out, use a little paper towel or a cloth to wipe down all of the excess wax from the outside, and you're done. Don't worry if you don't get all of the wax off right away. It's very easy to just use a heat gun on a low setting or even a hairdryer to soften the wax again, and then you can get off any last remnants. And with that, you are officially completely done. Time to install them into your guitar, like this custom new shape that I'm developing here. I'm calling it the Vanquisher. And well, I'll have a video about this guitar very soon, as soon as I finish it up. And there you will also be able to hear these pickups. Right now, this guitar is not quite ready for strings yet, so I can't really play these pickups to you, since they are custom angled to fit this guitar specifically. They will not fit in any of my other guitars. But that's the cool thing about making the pickups in this way, is you can have completely custom pickups for every one of your guitars. Now, of course, I got 10 bass plates, but they just cost $5 for 10 pieces, and even if you go to a pickup part supplier, you'll pay probably like $2 or $3 for a bass plate. So by using only 2 of them, I already covered that cost, and they're completely custom. Same for the bobbins. They don't really cost that much more than the off-the-shelf ones, and you can customize them, you can add your own text in there, and all of that is just thanks to the great online services from PCB, which you can check out, of course, linked down below. Thank you again for sponsoring this video. And with that, I think we're at the end. If you like this video, please leave a like down below. Also, comments, subscribe, all of that good stuff. You don't want to miss me finishing this guitar, and you can also probably see here in the background, I'm still working on the CNC. It's progressing, but it just takes a bit of time. That's why I have this video here in between. So with that, thank you guys for watching, and until next time.